Lesson 3-5, which is on Notes page 40. Once again, not a lot going on here on the page, which leaves you lots of room for examples. We're looking at inequalities with variables on both sides. You solve them just like equations. Is this starting to sound familiar? Just like equations, with the exception of the fact that you still have to pay attention to reversing the inequality symbol when you divide by a negative number or multiply by a negative number. Just like with equations, we collect all the variable terms on one side and we collect all the constant terms on the other side of the equal sign. Write down your first example here on page 40 somewhere. 4m minus 3 is less than 2m plus 6. If you think you know what to do, go ahead and pause the video and give it a try. Now that you're back, let's go through it. I always like to keep the variables positive whenever possible, so I'm going to take away 2m's from both sides, and that leaves me with 2m minus 3 on the left and positive 6 on the right. I'm going to add 3 to both sides, and I get 2m's are less than 9, so m is less than 9 halves. You can leave it like that. If you're dying to write it as 4.5, you can, but only because it's a terminating decimal. And as far as doing the graph, you can always just still number it, 9 halves, 10 halves, 11 halves, with whole numbers or without. Either way would be okay. If you prefer to number it, 4, 4.5, 5, 5.5, that's fine. You can also number it in whole numbers and put the dot halfway between. So I've got open dot, less than, okay, so arrow to the left. Okay. You can check both the number answer by multiplying. So 4 times 4.5 is 18, minus 3 is 15, right? And these should actually be equal right now. We're checking the number. 2 times 4.5 is 9. 9 plus 6 is also 15. So the number works, even though it's not less than. Remember, we're checking the related equation. And then for less than, pick a number less than 4.5. My favorite number less than 4.5 would be 0. Right, so I've got 4 times 0 minus 3 is negative 3, and that's supposed to be less than 2 times 0 is 0 plus 6, and definitely negative 3 is less than 6. So 2 ways of checking to be sure that I am 100% right. Write it down. 5t plus 1 is less than negative 2t minus 6. Pause it, give it a try. Now that you're back, let's change colors pen. Alright, I'm going to get all my t's together on one side. I could subtract 5t, but I don't want to. So I'm going to add 2 t's to both sides. I get 7t plus 1 is less than negative 6. Be careful there that you zip zap that. Drag that negative with you. Subtract 1 from each side. And I get 7t is less than negative 7. So t is less than negative 1. No flipping because you're not dividing by a negative number. And graph it out real quick. Open dot, less than, we're good to go. Double check, negative 5 plus 1 is negative 4. That should be equal to negative 2 times negative 1 is 2 minus 6, which is also negative 4. And then you can also pick a number underneath your arrow to double check the direction of the arrow. I'm not going to do that one right now. I'm trying to conserve time here. Don't forget that you might have to simplify on one or the other or both sides of the inequality. Combine like terms, distribute, etc. Before you start moving things from one side of the inequality to the other, it's always best to have it as simplified as possible. So here we've got a lot going on. Write it down. 2 times the quantity k minus 3 is greater than 6 plus 3k minus 3. So on the left, I see an opportunity to distribute. I'm going to get that done. 2k minus 6. You can pause this if you want, do it yourself, and then come back in just a moment. On the right, I'm going to do 6 minus 3 while I have a chance. So let's get rid of that. And actually have negative 3 plus 3k. Okay, now I'm going to get all my k's together on one side. I've got more on the right, so I'm going to subtract 2 k's off of the left side. And I get negative 6, don't lose that negative sign, is greater than negative 3 plus 1k. And then I'm going to add 3 to both sides. And I get negative 3 is greater than k. Okay, which means k is less than negative 3. Oh, no number line. I'll draw a quick one here. Negative 3, negative 2, negative 1, negative 4, 0. Squeeze it in. All right, negative 3 is less than k, so negative 3 is greater than k, so k is less than negative 3, arrow to the left. And the other easy way to check, if you don't like having to check something that's underneath the arrow, you can also check something not underneath your arrow, like 0, right, and make sure that it's false. So it's kind of the opposite idea, because using 0 is always a really easy check. Right? So if I plugged in 0, I'd get negative 6 is greater than, let's see, negative 6 is greater than 6 plus 0 minus 3. Right? And negative 6 is not greater than positive 3. That's false, and my arrow's not going that direction, so I know that my arrow is correct. That's kind of the opposite way of checking. Some of you, I probably just lost you. You can check the usual way with something underneath and wait for it to be true. Now we get to some new information, and it's the new kind that lots of you don't like. You didn't like the no solutions in Chapter 2. You're probably not going to like these so much either. Some inequalities are true no matter what value you put in for the variable. Okay, the solution set for those ones is all real numbers. Some inequalities are false no matter what value is substituted for the variable, so they have no solutions. Okay, meaning that you put the empty set or the 0 with the slash through it. You might want to write down a slightly shorter version of that. Okay, this is actually what they're going to ask you to do on the page. So if you're not sure how to know when you get those, put something down right near those boxes. Okay. How do you know that you have an all real number or an empty set? Okay. When you simplify and all the variables disappear, you're left with an inequality that has no x's, no n's, whatever the variable is in it, and there's numbers left at the bottom. If the numbers turn out to be true, then it's all real numbers. So something like this, 2x minus 3 is greater than 2x, hold on, you're not going to be able to see all of that. Let's do it over here. 2x minus 3 is greater than 2x minus 5. Right? The x's drop out when you try to subtract them, and you're left with negative 3 is greater than negative 5. That's true. Right? So all real numbers are the solution. Okay. Now if we look at another one like this, 2x minus 3 is greater than 2x plus 5. Right? Now when my x's cancel each other out, because they're the same on both sides, I have negative 3 is greater than 5. Well, that's false, right? So this is one where you would have then no solution. Let's look at two more examples like this that you can put in the boxes right there on page 40. 2x minus 7 equals 5 plus 2x. Oh, that must be why I had the 2x's in my head, because I've been looking at this slide recently. So we see that same variable term on both sides for any number 2x, right? When we go to subtract it, right, try to get our variables together, we end up with nothing, right, with the variables. So we just have to decide, is negative 7 less than or equal to 5? And it is, so that means that any value of x makes this true. So all real numbers. Make sure you actually write down the all real numbers part when you would have a test or a quiz or homework. on this, because just showing me -7 is less than or equal to 5 doesn't get you all the way there. One more like this. This is our last slide. We've got a lot going on, so get it written down. Start simplifying it. Feel free to pause. When you get stuck, come back. When I distribute, I get 6y minus 4 is greater than or equal to 6y plus 21. I'm going to get my like terms together here, and I've got 6y plus -8 is greater than or equal to 6y plus 21. Now this is the part where a lot of you got lost on the test when you went to, well, first of all, a lot of you added instead of subtracting, or subtracted when you should have added. So yes, right, it's the opposite sign, and then really they do all cancel out, and you're left with, in this case, -8 is greater than 21. Well, -8 is not greater than 21. That's false. Right? So that means there are no numbers that you can plug in for y to ever make this be true. Now, if I've left you with if you're wondering things, if you've got questions, now's a really good time to jot them down on page 40 so that you can ask me those questions tomorrow, right? That way you'll remember. That's it. See you tomorrow.